Welcome back, everybody. Good to see you all again. You'll see Miss Jay's there on the call with us as well today. Good morning, Miss Jay.
Good morning.
So today is our second part, which is the last part of algebra, of equations. And so it sort of follows that we did the 3 sessions on algebra, which followed our stuff on numbers, and they've all been building and building, and we sort of keep using all of those skills that we've learnt already in our next piece, and that continues today. So before we do these sorts of equations that we want to do today, you want to be pretty confident with your negative numbers and your fractions. You want to be pretty confident with your algebraic skills, adding and subtracting, multiplying and dividing, simplifying. You want to be able to solve some of those basic sort of type 1, 2, and 3 step equations that we did last week. Good morning, Jody. So, got some bad news, unfortunately. This is our last lesson. So, yeah, it has been a fantastic term to be able to be working with you guys, and the recordings will still be available, so you'll be able to go back and watch them whenever you like. So that's the address for the recordings. Make sure you write it down, mathspace.co/au/academy. The slides that I've used for all the weeks will be there as well. So you'll be able to download those, and then you'll be able to work through the different problems as we've done them, or you could watch the videos. The good thing about the videos is you get to do it at your own pace. So you get to pause, you get to do the work, and then you get to continue and then watch me sort of do the work. It's a bit like having a tutor work with you, or so someone leaning over your shoulder. You can have a go first and then watch the rest of the video and see how it turns out. But yeah, so unfortunately this is our last lesson. We launched this as a bit of a mission to help teachers and help students when the world went a little bit crazy with COVID. And so what we wanted to do was just put ourselves out there and say, well, let's see how we can help. So we started doing these lovely lessons, and I got to meet lots of you lovely kids. I think at the peak we had about 30 each week, so that was pretty good. But you'll know, if you've been coming, that the number of people who are coming each week is declining, and that's because school's going back. So Australia did such a great job at being able to contain the virus that schools were able to go back a lot earlier than they first thought. Victoria, for example, which is where I live, they were really sure at the beginning of at the end of last term that there would just be remote learning for all of term 2, but that hasn't been the case. And so most of you, if you're not normally a learn from home student, would be going back to school anytime soon if you haven't already. So yeah, this will be our last lesson. So what we do hope is that that we've been able to help you with some of these basics. So we talked about the numbers and the algebras and these equations, and they're pretty important topics to be able to master. If you can go back over even the videos that we've just done for the last 8 weeks, and you can be pretty confident in that stuff, I think it will set you up really well for the rest of your high school maths. So on that note, we do say thank you. So just as our introduction and our quick test on getting all hooked up with our pair deck, I'm going to flick now to the screen so you can join in, and then there'll be a question straight up just about something that you've liked about this sort of online learning classes that we've been doing with you. So I'm going to flick now to the class. There's the code that you need today. It's joinpd.com, and the code for today is ZJERF. Zesty Jacks evaluate red flashlights. So if you can jump into there. Don't forget to take note of your little animal or your nickname when you first log in. That way, when I am looking over your shoulder, as you sort of, so to speak, when I'm looking at the work that you're doing, I can comment and give you prompts as you go. So I think so far we've got like a zebra and some sort of dinosaur. Okay, so it's only a couple in. We'll just give you a little bit more time. So just in a different part of your browser, joinpd.com, and then you type the code ZJERF. The code will still be there and Miss J be around on the chat to help you. I'm just going to start that class so we can get to that first question. What have you been enjoying about these classes? So it might be, you know, time, it might be just seeing it done a different way. It might be something specific about learning online that you like. But I'm really interested to know what sort of things you've liked about these classes. Interesting maths instead of easy maths. Well, that's good, fantastic. I'm glad we could help people where they were stuck. That's really important. Okay, we've only got 4 people in from the 7 in the room. So if you're in the class and you want to be able to interact and get some feedback on the equation solving that we're doing later, you do need to join in, joinpd.com with the code up in that top right corner. If you just want to watch and do the work on your paper, that's absolutely fine. Just give you one more chance to go into that code, into that page in the code if you like. But as it is, we've only got about 4 people in. Okay, where are we in our learning? So like I said, we've been doing a lot of the basic stuff and we've been building on these little building blocks each week. So last week we did the first part of equations and we were solving equations with algebraic manipulation. And we also looked at a special solving method called backtracking, which was sort of just looking at what's happening to the number in terms of order of operations and then just working back one step at a time. And this week, we're just extending those to equations that are a bit harder, basically. So there'll be ones that involve brackets, and there'll be some that should say variables on both sides. There'll be some that involve variables on both sides of the equation. So as usual, I'll remind you about this website. It's a good website and it will stay post our classes as well. So all the rest of the Year 8 courses has videos on this website. So that could be something you can also use to supplement your learning for the rest of the year. It's wootube.mathspace.co and you'll see that there's Mr. Eddie Woo there and he talks through his class and he's recorded it. So you'll be able to see how another teacher explains the same sort of concepts that you'll be doing in your class. Now, this was the challenge that I left you all with at the end of last week, and it was a pretty good one. Some might call me crazy, but this is what we left you with. It was something just to sort of push yourself a little bit and see how well you could apply some of the ideas that we'd done last week. So I'm going to start with this. So this was the question that we left you with, and there'll be a little bit of a revision about this backtracking method that we used. The idea is you start by looking at where the variable is. So in this case, it's right here, there's our x. And then you want to build, by looking at order of operations, what's happening to the x. So I left you with the first step was we times it by 3. So if we've times it by 3, what would we do next? Feel free if you like, because there's not many of you to maybe Miss Jo, we can just open the chat up. There's only 6 or 7 kids today, so feel free to throw in the chat what you think would happen next. So what next is, keep going with that. Yes. Is we're going to finish expanding or evaluating the brackets, because our order of operations sort of says to look at the brackets first. So if we've already times it by 3, the next step will be to -5. and after we minus 5, well, now at this point we'll have evaluated the whole bracket. Once we've done that, we need to do this multiplication out the front of the bracket, so then we would times it by 4. And so now we've sort of done this whole piece. And after that, we would want to do the numerator of the fraction. So we'll subtract 6, and the last step would be to divide by 3. So that is what's happening to the x when we sort of just look at it in terms of step by steps. You know, if we were to substitute in a value of the x here, what are you going to do to try and evaluate the answer? That's sort of the idea. Now, to solve the equation is the idea of being able to go backwards. So untangling that, you know, this sort of mess, if you like, just one step at a time. So we look at this idea of just going, you can do it in 2 ways. You think, well, what number divided by 3 equals 22? So we're just looking at this very first piece. Or we look at reverse operations and we say, well, what's the opposite of divide by 3, which is times by 3? So when we're going backwards, we're going to take the 22 and times it by 3, and we'll get the answer of 66. Okay, and then we just keep going with this reverse operations idea. If we were subtracting 6, the reverse operation is to add 6, 66 plus 6, 72. Okay, keep going along. We've got a times by 4, so the reverse operation of times by 4 would be divided by 4. We want to take 72 and divide it by 4. Now, if you don't know that off the top of your head, you've got a couple of options. You could do like a little short division on the side of your paper. You could use your calculator. I tend to sort of chunk it up a bit. So 72 is 40 plus 32. I can see that when I divide them by 4, I'll end up with 10 out of that piece and 8 out of that piece. So my answer is 18. Okay, so now we've got to subtract 5. So the reverse operation for subtract 5 is add 5. 18 plus 5 is 23. Wow. What have I done wrong there, Miss J? No, maybe I haven't. And then we would need to divide that by 3. I gave you a really hard one. See, this would be 23 over 3. I was probably meaning for that to be a number that was divisible by 3, but it didn't turn out that way, but it doesn't matter. I think that's still the answer. So how'd you go? How'd you go with something like that? The key thing here is not the final answer. It's never really the final answer unless you need to do something with it. The thing about these sorts of skills is it's really just this idea of understanding how this equation was built, because if you know how it was built, then you can unpack it. So we're really looking at this idea of how was this built? That's this idea of bound to saying, oh, I see, we times it by 3, and then we divide it minus 5, and then we times 4. Like this idea about really building those expressions, that's a really key point. The second one was then being able to undo that one step at a time, reverse those operations, and end up with a final answer. So you will have answers that are weird fractions, you'll have answers that are crazy decimals, and when you get on to further maths, you'll have equations that have square root signs and all sorts of weird and wonderful things. The answer, like I say, is really one of the least important parts of all of this. It's all of this process that underpins it, which is what we're wanting you to learn and wanting you to demonstrate that knowledge of. All right, so that was last week's challenge. Let's get on to some of today's equation stuff. So, this is the second half of our particular chapter 5. Now, remember I said last week that solving equations is like undoing this knotted tangle earbuds. It's exactly the same. It does not matter how hard the equation is. This is really still what we're doing, untangling it one step at a time. The biggest mistake I used to see in students' work at school when solving equations was them trying to do too much at once, too much in a line of working. And if you do too much at once, you're going to miss things. You'll make little mistakes. So just do it one step at a time. The benefit of that is if you're just doing one little step at a time and you make a mistake, then the person who's marking your work, like likely your teacher, is going to see that and go, oh, I see, they've just made this one mistake. All the other mistakes that you make after that, you know, it's kind of like accumulated error. Doesn't matter as much because they can see you just missed this one thing. That's the benefit of really showing your work. So, as I've said, what we did last week really focused on that idea of order of operations, being able to see how those expressions are built and that step-by-step approach to unpick that. That method that we used with the boxes only works when the variable is on one side and occurs in just one place. This week's solving equations will be really focused on where the variable occurs in more than one place or on both sides. So we can't use that method that we've developed, but we can use those more formal methods of reverse operations. So that's where we're focusing today. So let's just continue ourselves, remind ourselves about this, this formal approach to solving equations using reverse operations. So I'm going to do this particular question. Feel free to work ahead. You can sort of throw some lines of working at Miss J or throw her the final answer. So we're just reminding ourselves of the process of solving equations using reverse operations. So here's our equation, and our first step will be, it's kind of like a game. The aim of the game is to get the letter on its own, in one place on its own. So you need to sort of move everything else away. So you probably hear your teacher say phrases like isolate the variable. So that's sort of what we want to do. We want to get it on its own. So at the moment we've got this whole fraction here, it's being divided by 4. So my first step is going to be times both sides by 4. When I do that, I'm doing this reverse operation of divided by 4. That will leave me with 5m plus 7 on the left and 32, which is 8 times 4 on the right. Okay, we're still playing this game of isolate the m. So I can see it here. I want to get that on its own. So my next step will be to remove this plus 7, which is sort of hanging off on the edge there. So I'm going to subtract 7 from both sides. When I do that, because I've done the reverse operation, I'll have plus 7 minus 7. Those two will cancel out and leave me with just a 5m on the left-hand side. On the right-hand side, I've got now 32 minus 7, which is 25. And now I've got down to a one-step equation, and the one-step equation is kind of just like that final step of, well, what's the answer? 5 times something is 25. If I divide both sides by 5, then I get my m isolated on one side, all on its own, and the answer is 5. Now, you remember I said last week about you can't really sort of just get it wrong because you can always substitute it back in and check. So that's what we'll just do very quickly. If m here was 5, let's evaluate it and double check, okay? So we'd have 5 times 5 is 25, plus 7 is 32, divided by 4 gives me 8. So we know that m is indeed 5. Okay, it's really important to do that step and check, especially when you're doing, your more formal assessment, like your tests and things. If you've got time at the end of your paper, go back over and substitute in your answers and check, because you might just go, oh, hang on a minute, that didn't work, and it gives you an opportunity to correct your work. Definitely check anything that involved a negative or a fraction, because they're real popular mistakes that kids make. Okay, so that's just reminding yourselves of this process of reverse operations. So we have basically these reverse operations that we've used here, the times 4, the minus 7, and the divide 5, was the undoing of what's happening to this m here. Okay, so we had to know our order of operations and then know what was the last thing that we did and undo that first. So there's 2 options here. Now, this is really the revision from last week, just to make sure that we've got it. I have made these ones a little bit harder. They've got negatives in it. Pick one, doesn't matter which one, and just throw your if you didn't join into per day, then that's okay. You can throw your responses towards Miss J. That will be fine. So you're going to solve one of those. You don't have to solve both unless you're pretty quick and then you sort of get there before we've sort of finished on this slide. Okay. Where are we at? Got a few there. Okay, what I'm noticing, Miss J, is we don't have any kids in our pair deck, so I might just do the examples. It seems like they've had some tech issues or they've decided not to join in today. So just throw in the chat there if you would like to be able to do this interactively to get feedback from me as we go. If you do, then we can give you the login details again. Otherwise, we'll just do them as some examples together. Okay, so I'm going to go through this first one. Let's start here. Okay, so let's do 3 outside of m minus 5 plus 2 equals minus 4. Okay, so remember the aim of the game is to get the letter on its own. Here's the m. We want to isolate it, which means move everything else away. So our first step here will be this straggly 2 that's happening on the end. So we're going to subtract 2 from both sides. So when I subtract 2 from both sides, on the right-hand side, on the left-hand side, sorry, I'm left with 3m minus 5. That hasn't changed. And over here, I'm going to have minus 4 minus 2, which is minus 6. Maybe I can ask the kids in the class to make sure that you're keeping an eye on my calculations too. Throw to Miss J if you think I've made a little error anywhere. Okay, what's the next step? So now we've got 3 times it by this whole n minus 5 thing. So if I divide everything by 3, that would be my next step. Because at the moment on this left-hand side, everything's been multiplied by 3. So the reverse operation would be divide 3. That will leave me with m minus 5 on the left. It would be in brackets, but when there's nothing sort of outside of it or tailed on the end, we don't need to write the brackets. That's one of our math conventions. Over on the right-hand side now, I have negative 6 divided by 3. So numbers first, 6 divided by 3 is 2. And then I look at the signs, they're different signs. So the answer is negative. Okay, I've got one step left. I've got a one-step equation left. I've got something minus 5 is minus 2. The operation is minus 5. So if I add 5 to both sides, that will reverse that. What I'm left with here is m minus 2 plus 5 is 3. Okay, we can always put it back in and check. So we'll do that very quickly. If we put it back into our original equation, if m up here was 3, and I evaluate that, then I get 3 minus 5 is minus 2. That was that step. Times it by 3, negative 6. That was that step. Plus 2 is negative 4. And that was that step. Okay, we've got this one over here with the fraction. Let's have a go at that now. Okay, k plus 1 all over 5 minus 4 equals minus 2. What do we think the first step is? Throw it in the chat there. What do we think the first step is? What's the last thing that's happening to this evaluation on the left-hand side that I need to try and undo? Just couldn't quite see the chat there. Yeah, well done. Well done, Bella. Absolutely right. So that's what we're going to do first, is we're going to add 4 to both sides. Here we go, add 4. So when we add 4 to both sides, what I'm left with is the fraction on the left, k plus 1 over 5. On the right-hand side, I've got minus 2 plus 4. That leaves me with just 2. Okay, what's the next step? k plus 1 all over 5. So we've got this whole fraction piece here. So I'm going to get rid of the denominator. So if it's divide by 5 at the moment, we're going to times it by 5. Yep, we're done. And then we've got on the left, k plus 1 equals 2 times 5 is 10. One-step equation now, something plus 1 is 10. That one we know straight up. That is k equals 9. Okay. If you worked along at home with that one, well done. Close that. Moving on. Okay, remember when we looked at expanding brackets? Now we did this in our algebra lesson. We looked at the distributive law, and remember we looked at it, in terms of like the area model with rectangles and the like. We can also use this when we're solving equations. So in this particular case, we could solve it in two ways, and I'm going to show you two ways. The first way is the way that we've just done it. So for example, the first way would be to go, okay, well, we'll just divide both sides by 4. And that gives us x plus 5 equals 8. Something plus 5 equals 8. We can see that x equals 3. That's the first way. That is not expanding the brackets. That's just dividing everything by 4 to move it sort of away. Now, that was a good strategy because firstly, there was just sort of the one product on the left, the 4 times this bracket thing. The 32 was divisible by 4, so that was kind of nice too. Sometimes it's not so nice, and so we employ a different strategy, which is to expand the brackets first. So I'll show you how we do that with this particular question, and then we'll move on to some questions where they're a bit harder and it makes more sense to do this. Excuse me. So here we have the same equation for x plus 5 equals 32. And now we're going to do our expanding of the brackets. So remember what that looks like is we go 4 times x is 4x. 4 times 5 is 20. And that equals 32. So we've expanded the brackets. Now we use our normal, isolate all the pieces tools that we've got. So now we just do the minus 20. That gives us 4x equals 12. And then we have 4 times something is 12. We can see that x equals 3. Luckily, it's the same as what we got before, as it should. It shouldn't matter which way you solve the equation. You should always get the same answer. So there's two methods there to solve the same equation. I kind of think this first way was a bit easier for this particular question. Now, that's the thing with maths, is that we sort of show you lots of different ways to do kind of the same thing. And the most important thing for you is to work out, when do I do that? Which sort of equation lends itself to this method and which lends itself to the other? It's exactly the same when we were learning how to do just numerical calculations. So for example, you may have learned a very simple numerical strategy of adding 9, which is to add 10 and take 1 away. Like, that's a really common sort of strategy to deal with adding 9s. And you sort of had to know when that was useful. Is it useful when you're looking at, say, adding 9 to 2? Maybe not. But is it useful when adding 9 to 235? Maybe that's a bit easier because you can sort of keep track of those larger numbers by adding in multiples of 10. And so too is true with equations. You want to sort of know when should I expand these brackets? In this case, maybe this dividing by 4 was just easier to begin with. But the best thing is it doesn't matter. You can expand the brackets, you'll have an extra step, you'll still get to the answer. So it really doesn't matter. If you did expand the brackets and later on someone says, oh, but I did it this way and it saved a step, doesn't matter. Okay, so just go step by step. So, as I just showed you, you don't always have to expand first, but there are cases where if the variable appears in more than one place, or if it appears on both sides, or there's multiple pairs of brackets, it makes sense just to tidy it up a bit first. So that's what we want to do. What we're going to do is we're going to expand this left-hand side, tidy it all up, collect our like terms. We're going to use our skills of simplifying algebraic expressions to make it a little bit simpler, and then we start solving. So we're going to firstly expand the brackets here. So 4 times 2x is 8x. 4 times -6, -24. I'm not doing anything with this at the moment, so I'm just going to keep writing that out. And my right-hand side is still 16. So we've expanded the brackets, and now you'll see we've got x's in sort of different places. So we want to combine them together. We want to sort of move all of the terms with the variables to one place and all of the terms with the numbers to another. And that sort of moves us towards solving. So we're going to combine this 8x minus 3x to get 5x. The 24 is still there, and it still equals 16. So all I did was combine those two terms together. And now we have something that looks more like the equations we've been solving. The variable appears in one place, and we want to now isolate that to solve. So at this point, you could say use your backtracking method, or we can just use our reverse operations. So the first operations is plus 24, which gives us 5x equals 16 plus 24 is 20, 30, 40. 5 times something is 40. Well, that something must be 5 eighths of 40. Yeah, well done, Bella. Okay, so the key point here was what we noticed was that the x's appeared in more than one place, and we couldn't just jump into solving. We had to do something first, and that something was simplify, gather all the like terms together, and then we were able to move forward. So the next one is a your turn slide, so we'll have a couple of examples there to do. So we don't have anybody in doing the turn, so I'll give you a moment now maybe just to have a go first on your paper in front of you. Maybe, yeah, if you want some help, you can ask Miss J or I in the chat if you don't know where to start. But certainly make a start, have a go, pick one. The idea is to expand the brackets, collect your like terms, and then you should be faced with the equation that you can start to solve. How are you going? Have you made a start, everybody? Now, some of these numbers look bigger than what we've been used to. Process is exactly the same. My first step is going to be expand the brackets, 5 times 2x, and then the 5 times 5. 10x plus 25. These last two terms I'm not changing. I'm just going to rewrite them. They haven't done anything with them. Now I'm going to start gathering my like terms. I'm going to join the x's together. I'm also going to join the numbers there together. So 10x plus 4x is 14x. 25 plus 6 is 31. And that still equals 59. And now we've got the equations that we're used to solving. And they always kind of simplify down to this sort of nice form at the end where there's just a couple of steps. So now to isolate the x, I'm going to minus 31 from both sides. Over here, 59 minus 31 will be 28. And now 14 times something is 28. If you can see straight up that that means the answer is 2, then you could jump straight to that. If you need to think about what that is, then you could do your reverse operation of divide 14, and you'll still get that x equals 2. Okay. going to also do the second example because there's two sets of brackets there. Okay, here we go. So we have 3 lots of 4x plus 6 minus 2 lots of 3x plus 5, and that equals 26. So we've got two sets of brackets to expand. And the first one here, 3 times 4x and 3 times 6. The next one here is minus 2 times 3x, remember the minus, and minus 2 times 5. So it's nice, a tricky one with the negatives there. 3 times 4x is 12x. 3 times 6 is 18. And then we're going to do the next bracket, which is negative 2 times 3x, which is minus 6x. Negative 2 times 5 is negative 10. And all of that equals 26. So this just comes straight back to our expanding brackets. So if expanding brackets is a bit confusing to you, then you would go back to our algebra chapter and you'd practice some of that distributive law stuff. Okay, now I'm going to combine my like terms. My like terms are my x's, so I've got a 12x and a negative 6x there. And the numbers, I've got an 18 minus 10. So I'm going to combine these like terms. 12x minus 6x is 6x. 18 minus 10 is 8. And the answer there is 26. Okay, now we're back to our nice looking equation. This is a two-step equation. We've got 2 steps to go till we get to the final answer. I'm going to isolate the 6x. I'm going to subtract 8 from both sides. We've got 6x. 26 minus 8 is 18. Now we've got 6 times something is 18. You might be able to jump straight to the answer there and see that that is 6 times 3 is 18. Or you can do your reverse operations and divide both sides by 6. Okay, so you'll see there's a lot more numbers on the page. There's a lot more going on. But as you were listening to my words, it was one step at a time. Expand the brackets, collect like terms, and then isolate to solve. That process won't change. Okay. So sometimes we need to do rearranging and simplifying first, as we've just seen on those 2 questions. So that's definitely the case if there are variables on both sides. So at the moment, we've just done some examples where there are variables in more than one place, but they're still on one side. If there are variables on both sides, we have to get them together. So you're going to have to do some reverse operations and put them together. So my tips are still the same. Expand the brackets, put all the letters on one side, and then we'll solve by moving all the numbers to the other. Okay, let's have a go at a question. This is a very simple one. We've got no brackets. We've got sort of not much else going on, but there are letters on both sides and we have to get them all onto one side first. So it doesn't really matter which way you try and do it, as long as you do one step at a time. So that what I mean by that is it doesn't mean if you try and move the 7x to this side or the 3x to the other side, it doesn't matter. With an equation, the word equation actually means equal, okay? So we've got 2 things that are equal on each side. We've got the left-hand side and the right-hand side. You can move things around from left to right and right to left, as long as they stay equal and you're doing the same to both sides and you keep that balance, it actually doesn't matter which way you move it. Most people try and move the smaller things to the side of the bigger things. But again, it doesn't matter. I think if you do enough practice, you'll start to realize which steps that make it easier for you in the long run. But it's certainly better for you to be working that out than to try and be taught a whole heap of rules. So in this case, I'm going to move the 3x. I'm going to subtract 3x from both sides. So that's following that sort of idea I said where sometimes it's sort of easier to move the smaller things towards the side of the bigger things. So the reason I'm doing that is because I want all the x's on one side. So it's still a reverse operation. This was a little plus 3x and now I subtract 3x, so they'll cancel each other out. It's exactly the same as if it was a plus 3 and I were minus 3 from both. So they'll cancel each other out. Right hand will be left with 12. On this side, I'll have 7x minus 3x. Now, you might like to write that out as a little step, or you might be able to combine them straight away. 7x minus 3x is 4x. Okay, now we've got a one-step equation. 4 times something is negative 12. We've got some great answers coming through. Well done, Josephine and Bella. And we see that when I divide both sides by 4, I get that x is negative 3. Now, let's just substitute it back in and check that our left-hand side and our right-hand side are equal. On our left-hand side, if x is negative 3, then we'll have 7 times negative 3, which is negative 21. That's not a great colour. Let's go something brighter. There we are. On our right-hand side, if x is negative 3, I'll have 3 times negative 3, which is negative 9. And I subtract 12 and I'll get negative 21. So we know we're right. Okay, we've got 2 examples now on a your turn slide. So in your books, pick one of these. It's an exercise in bound to move all of the variables to one side and then solve. The first one is very similar to the one we just did, where there's just a couple of steps. The second one has an extra number in it, so there might be an extra step in there. So if you want a harder one, choose the second one. If you think you're just learning, start with the first one. Should have used different letters so that we could tell which one you were solving. Okay. 8x equals 6x plus 10. Where to go at that one? So we're going to move the 6x over here. The reverse operation of plus 6x is minus 6x. I'm going to do that to both sides. What that does is it gives me 8x minus 6x. If you need to write that out, that's absolutely fine. If you can jump straight to the answer, you can see that that would be just 2x. Equals over here, well, they'll cancel out, which will leave me with just the 10. 2 times something is 10, x is 5. That's great. Okay, the next one had an extra step. 7x plus 6 equals 3x plus 22. So first step is I'm going to move the x's to one side. I'm going to move this one over. Going to subtract 3x from both sides. That's going to give me 7x minus 3x is 4x. I haven't done anything with the 6. It's still there. And the 22 is still there on this right-hand side. My next step will be subtract 6 from both sides. 4x. 22 minus 6. Yep, so 16 is right there. And then x equals 4. 4 times something is 16. Okay. Well done. Okay, still going to get a little bit harder. Now we've got x's on both sides and brackets. Okay, so now we've got, the tips really are always, it's kind of like auto operations, right? Brackets first, you know, powers, all that sort of stuff. Then your multiplication and divisions, then your additions and subtractions. So it's the same thing with solving equations. The process is still expand them out, gather all your like terms in one place, put all the letters on one side, all the numbers on the other, and then you'll be able to solve. So I'll do this one as an example. I've got 2 on the next slide that will you'll be able to try. So here, this is how we do something that looks a bit more complicated like this one. This is about as hard as they get. Or maybe you'll have brackets on the left as well. So at the moment, the left-hand side looks pretty simple. I'm going to leave that as it is. I need to expand these brackets. 88 will stay as it is. I'm just going to look at doing something with this piece. 6 times 5x is 30x, and 6 times -5 is -30. So I've expanded the brackets. That was this first step. Now I'm going to move all the letters to one side and combine all the like terms. So where are my letters? I've got a 3x here and a 30x here. Okay, so we can do one of two things. We can move the 3x over this way or move the 30x over that way. Doesn't make any difference which way we do it. So I might just move the 3x over here. That will leave me with 4 on the left and give me 27x here, minus 30 plus 88. Well, they like terms because they're numbers, so I can combine those together. 88 minus 30 is 58. Happy with that? Okay, let's now move the 58 because we want the letters on one side and the numbers on the other. So I'll move 58 over here. They're getting some big negative numbers, but try not to be spooked by that. It's still just a number. It just happens to be negative. So on the right-hand side, they'll cancel out, leaving me with 27x. Now I need to know what 4 minus 58 is. So it's going to be negative, because that's a very large number, 54. Okay. Now I just need to know 27 times something is negative 54. Now, if you can't see straight away that that might be something like -2, then you just do your reverse operations. You divide both sides by that value, negative 27. This gives me an x on the right-hand side, which is good because that's my x equals. Over here, I've got negative 54 divided by 27, which is -2. Now, you'll notice this is the first time that we've got an x on the right. We've got -2 equals x. That is absolutely fine because we're actually saying they are the same, therefore x is -2. You see a lot, and I've done it up until now, always people putting the x equals on the left-hand side. That is a convention that if we were to state our answer, we would say, so therefore x equals -2, because we tend to read from left to right, okay? We don't say, therefore, -2 equals x. Like, we just sort of tend to read that way. But as a mathematical statement, it doesn't matter. You can solve and put that variable on the right-hand side. Okay, so it means the same thing. The important thing about this statement is that they are balanced and that that is a true statement. Okay, so that is absolutely correct as a final answer. How'd you go with that one? You follow those steps okay? So here we are, 2 monster equations, but it's the same thing as what I just did, okay? We've just got an extra set of brackets here on this left-hand side one, and this one is pretty much exactly like what I've just done. There's some more negatives there, but it's all the same, okay? And this is like the hardest of the hard question in a Year 8 book. So if you can do this, you've pretty much nailed Year 8 solving equations. I might just do one of these. I'll do the hardest one with the 2 brackets on it. So maybe if you're going to do a question with me, you would spend some time just looking at this one here, and I'll start that one in a few minutes. I'll just give you a few minutes head start because there's a bit of work involved in that one. I should have had my think music ready. I said I would. What about it? As I've mentioned before, I am a classical pianist, so I play the piano. There's actually some research that supports the fact that listening to classical music, especially with a special cadence, bit of Bach, bit of Mozart, that sort of era, and the cadence and the way that those time signatures work actually helps thinking. So if you're going to play music in the background, you need to pick some classical music. Okay, hopefully you got a head start. I'm just going to start talking it through so that those who are a bit stuck. So brackets on the left-hand side, we've got -5, a -5x, a -5 and a 5. So the first expansion there will be 5 times 5 is 25, and they're both the same sign, so it's positive. The next one is -5 times 5, which is 25, but they are different signs, so that is negative. So that's the left-hand side expansion. On the right-hand side, I've got 7 times 4 is 28x, both positive. 7 times 8 is 56. They're different signs, so the answer is negative. And I still have +37. Okay, what I'm going to do first is just this piece. Tidy up these large numbers on the end. And keep everything else the same for now. Remember, if you just did one step at a time, there's less room for error. So I'm going to leave everything else the same. I've got -56 plus 37. So if I just think about -56 plus 37, what's the difference between those two? Looks like, what is that going to be, 19? Is that right, Miss J? And the -56 is larger, so it'd be -19. So if you need a calculator, that's fine. Okay, so now the goal is, remember, letters on one side, numbers on the other. Doesn't matter which way we do it. So I'm going to move the 25x over here. Let's do that as our first step. That leaves me with nothing here, just the number 25. Over on this side, 28 minus 25 is 3x. That's collecting those like terms, and the 19 is still there. So now I need to move the rest of the numbers over. So I'm going to remove this 19. To do that, I'm going to add 19 to both sides. So when I do that, I'm left with 3x here, and I've got 19 and 25, so the difference there is 6, and the 25 is larger, so it's -6. Now, look what we've done. We've taken this really massive, monstrous, ugly-looking equation and turned it into a one-step problem. Okay, that's why you're all mathematicians. Should send you all a certificate that says that. Okay, so now we've got divide by 3, both sides. Unless you know the one-step answer to 3 times something is -6, and you'll see that the answer is -2. How'd we go? Okay, one step at a time. Just one step at a time. That's pretty much it. That is the end of our equations. There's one example slide at the end here that involve fractions, but they're really much the same. What is it, 1055? I suppose I could do one of them. The process is still the same. You know, the idea is to get all of the letters to one side and all of your numbers to another. It's just if you've got these fractions like this, you need to deal with them first. So the way to deal with fractions is still, it's just like, you know, what's happening last, how do I get rid of it? So we'll do this hard one here to start with. It's the idea of getting rid of these fractional, the denominator pieces, because it makes it pretty hard to deal with. So how can I undo this operation of divided by 6 that's happening on the left-hand side? Well, my first step would be to times by 6. How do I undo this step of divided by 7 over here? Well, a way to undo that would be to divide times by 7. So we're really going to end up timesing both sides by both numbers. But I'm going to go through one step at a time, and this will be our last problem. Here we go. 4x plus 6 divided by 6. So a lot of people look at these ones with fractions and go, oh my, look, they're so hard. But it's no different to if it was a bracket. The bracket is just 6 outside of these things, and this is just all of these things divided by 6. So to undo the divide by 6, I'm going to times both sides by 6. Just doing one step at a time. That'll cancel out this left-hand side and leave me with 4x plus 6. That's looking nicer already. Over here, I'm going to have 6 lots of the 3x plus 12. I'm not even going to expand that yet. I'm just going to write it down. Okay, all I did was times this left-hand side by 6. That's what this has done. Times all of that by 6. Okay, my next step is going to be to times both sides by 7. So when I do that, I'm going to have, all right, well, I just want 7 lots of all of this. And I'm left with this stuff on the left-hand side. The nice thing about this is now we can do an expansion. We can expand both this side and this side, and we'll end up with just some single terms that we can start to collect together. So when I expand out the left, 7 times 4 is 28x. 7 times 6 is 42. On the right-hand side, 6 times 3 is 18x. And 6 times 12 is, so 10 is 60 and 2 is 12, so 72. My last step, second last step will be to move all the x's to one side and all the numbers to another. So I'm going to do a minus 18x on both sides. That moves all the x's to one side. This side they'll cancel out. That leaves me with 72 on the right. 28x minus 18x is just 10x, and I've got the 42. Now, this equation is starting to look a whole lot more simple. I've got 10x plus 42 equals 72. So let's just subtract 42 from both sides. That leaves me with 10x equals 30. 10 times something is 30, x is 3. Now, solving equations, it's not a trick. It's just doing the same thing to both sides to keep that balance, keep that equality true. We could do crazy things, you know, like we could just add 1 to both sides. That's fine. That's keeping the balance. It's keeping the equation true, but it's not helping us solve the equation. So what we're doing is choosing to do things to both sides that actually start to make this equation simpler. What you'll see is we move from this big equation here with these fractions and all these pieces to this little simple 2-step equation. They are exactly the same. They have the same value. All we've done is rearrange them a little. The value that x has in both of those instances is exactly the same. So that's what you need to keep in mind, is that it's really important to keep that balance and that equality the same on both sides. All we're doing through this process of solving equations is choosing to do things that take us in a direction, you know, that make the statements more simple. So in this case, we got rid of fractions, we expanded brackets, collected like terms. Like, we used everything. We used every skill that we've learned in the last 8 weeks in this one question. And there was a bit of, except for we didn't use any multiplying or negative numbers, but we pretty much used everything. We nearly used everything. Okay, so they can look like a really big hard mess, but really at the end of the day, they're just one step at a time. And the thing with equations is, if you do take the wrong step, but you've done the same to both sides, it doesn't matter. The equation's still true, and you can still keep moving forward from there. But one of the best things that you can do for any of this sort of work is to practice. So do a few, consolidate your learning. Any of your Year 8 textbooks will have a whole section on equations. There's heaps there to pick from. So you definitely do practice and get some proficiencies under your belt there. And that's it for today. I don't see any questions in the QA. I do want to say thank you very much to you all for coming today. I really appreciate that you've made the effort to come, and we do hope that we've helped your learning in some way. So do go and watch the video, do go and do some practice, and all the best.
Bye, everybody. Thanks for coming.